Everyone. This is another video on quantum mechanics, and here I'm going to be studying about spin angular momentum, that is S. So a lot of questions come from this chapter: angular momentum and spin angular momentum. So I'll be doing spin angular momentum today. A lot of questions we'll do concepts and all. Okay. So let's start with this chapter: spin angular momentum, which we usually denote with capital S. Okay. So we'll be solving questions from this chapter. So first of all, what is spin? Spin is actually what? Spin is your intrinsic property of the body of particles. Okay. So this property was derived from what? It was deduced from Stern-Gerlach experiment. Okay. It's a very important experiment. You should study this one. Stern-Gerlach experiment, and what are the consequences? What is the concept behind this? So you should study that. That's very important to understand spin. Okay. Okay. It's like this is kind of properties and definition all have kind of similar, um, analogous to angular momentum that we usually study, that is L. Okay. Anyway, let's study this one. So suppose there is a like if we operate spin angular momentum s square on any observable, that will be what? S whole into s plus 1 h cut square alpha. Okay, alpha can be anything, right? And this is the this is called what? This is called the operator. Okay, or this is the what? Eigenvalue. This is the eigenfunction. Okay, so this is the eigenvalue of this eigenfunction. The s whole into s plus one. All right, h cut square. Sorry, I missed this one. H cut square also. So s square like is associated with the eigenvalue s whole into s plus one h cut square. Okay. So s square is what exactly? S square is like sx square plus sy square plus sz. Okay, yeah. So we know that sx, sy, sz they all obey. What do they obey? They obey commutation relations. Okay, xs, sx, sy. What do you mean by commutation relation? We'll see. Okay, the following commutation relation. What are the commutation relations? Following commutation relations. Following commutation relation, that is sx sy commutation. So xy will give me z, right? I h cut sz. Okay, then sy is z. Very simple. It will give me I h cut sx. Then sz is x will give me I h cut sy. Okay, so the opposite of it will give me negatives like sy sx minus I h cut, all that. Okay. The quantum number of the spin, like in the z direction, that is sz, also has an eigenvalue, that is sz alpha is equal to ms h cut alpha. Okay, got it? Yeah. Okay. Okay. So suppose there are spin half particles. What will happen in case of spin half particles? Suppose there are spin half particles. Spin half. Okay. So spin half particles for particles like fermions and all, electrons. Okay. For example, electrons, protons and all, fermions especially. Okay, with spin half, we have like ms is what? Spin half particles, ms is actually plus or minus half. We'll have two values and two distinct eigenvectors. That is, we know s square. Eigenvectors of s square and sz will be what? Plus half and plus half and minus half. Okay, so corresponding to this plus half and minus half. So these eigenvectors are called what? Standard basis. These are called the standard basis, where if I apply this s square here, to plus half, it will give me what? S whole into S plus 1, h cut square, right? H cut square plus half again. This thing won't change. This will remain the same here. So S is half plus or minus half. So S whole into S plus 1, h cut square. So it will give me what? Half whole into 3 by 2. That is 3 by 4. Right? 3 by 4 h cut square. Okay? H cut square and plus or minus half. Yeah? Yeah? Alright. Okay. And if I SZ, if I apply SZ plus or minus half, it will give me what? Plus or minus h cut by 2 plus or minus half. Is it clear? Yeah? Alright. Okay. So, next is your Pauli matrices. You must have studied Pauli matrices. Study this one. After doing a bit of basics, we will go to the numericals. Pauli matrices. Okay. What are the Pauli matrices? Pauli matrices are usually sigma is equal to sigma x, sigma y, sigma z. Okay. And S, your S spin angular momentum is equal to h cut by 2 sigma. Okay. Like Sx should be what? H cut by 2 sigma x. Sy will be h cut by 2 sigma y. Hz will be h cut by 2 sigma z. Right? So sigma x, all these have also values. So sigma x is what? Sigma is 0, 1, 1, 0. Then sigma y is what? 0 minus I 0. Okay. And sigma z has 1, 0, 0, minus 1. So these are the what? Here S is the standard basis. Okay. So these are the Pauli matrices. Okay. And there is also commutation relation between the Pauli matrices. That is sigma x, sigma y is equal to. It's a bit different. It's not I h cut sigma that one. This is 2I sigma z. Okay. 2I sigma z. Sigma y sigma z is equal to what? 2I sigma x. Sigma z sigma x is what? 2I sigma y. Okay. These are the formulas for it. And if we square this Pauli matrices, you will have a the square will be what? It will be your unit vector. Okay. Let's check it. Sigma x square 0 1 1 0 into 0 1 1 0. So if we do it, so 0 1 0 0 0 0 1 0. Okay. So this is, if you see, this is your unit vector I. Okay. Alright. Yeah. Don't write it like this. Okay. Just write it like this a bit differently. Okay. Alright. There is another very important formula that you should remember. Like sigma dot A, sigma dot B. Okay. So that will be what? A dot B unit vector plus I sigma dot A, because this is a very important formula. You will have to use it somewhere along the road. Okay. Yeah. Where A and B are spatial vectors having the spatial coordinates. Okay. Don't read it as spatial. I used to read it as spatial. It's wrong. Spatial vectors. And space related. This is a adjective of space. Okay. Like coordinate space, all that. Right. Yeah. Okay. Now there is very important operator. These are called lowering and raising operators. Okay. We also study this in angular momentum, orbital angular momentum, lowering and raising operators. Alright. Lowering and raising. So almost similar. So if I write, so S plus raising operator is what? Sx plus Isy. S minus lowering operator is equal to what? Sx minus Isy. Alright. Yeah. So S plus plus half is equal to What is it? Hmm? Plus r should be 0, right? And then s minus plus r. So plus r would be what? H squared minus r. How do we do it? Can you tell me how do we do it? We'll do it, okay? We'll do it through numericals, right? It's not right. Don't write it. We'll do it through numericals. Okay. All right. Next is okay. Next is the rotations in spin space. You're adding rotations in the spin space. There is spin space. Okay. To find the representation of a state like alpha in a coordinate system, like which is rotated by an angle theta, okay, around the axis. See, suppose normally this is x, y, and z. Right. Suppose I rotate this whole system by an angle theta. So this will become your x dash. This is y dash, z dash. Okay, I rotated this system by an angle theta. Okay, yeah. So in the direction of a unit vector, there is another unit vector here. This is called u cap. So this is rotated in the direction of the unit vector. Okay, the whole system is rotated in the direction of a unit vector. So how will I represent? How will I represent the state now after the rotation? This is alpha. Okay, the state alpha. I will write it as alpha dash. That is exponential. Okay, minus I by h cut. Okay, theta u cap dot spin vector and alpha. Okay, got it. This is the representation after the rotation through theta in the direction of u cap. Right. So this is the representation. This is the new state after the rotation of the coordinate system. Please remember this is very important. Okay. So there is the rotation matrix. This is called what? This is the rotation matrix. Okay, we can say because this is we are okay. See here what I'm writing. This suppose U R rotation matrix alpha. So this whole matrix is bringing change to this state alpha, which is giving me alpha dash, which is the new system. So this is your rotation matrix. This is the because of this rotation, this state change into alpha dash. So this should be the rotation matrix. So this is your rotation matrix. Okay, so U R rotation matrix. You can write down U rotation matrix. This chapter is very important. Okay, most people usually leave it. U R is equal to what? Is equal to exponential minus I by h cut theta u cap dot inspector. Yeah, this is a rotation matrix because this is bringing rotation to the state we already had, that is alpha, and it is making it alpha dash. Okay, so what is the connection between them? This one, all right. Yeah, so let's write the value of it. So this can be written as the matrix. What is the matrix exactly? So the matrix is cos theta by 2, okay, minus sin theta by 2 e to the power minus I minus e to the power minus I phi, okay, sin theta by 2 e to the power I phi and cos theta by 2. Okay, got it? Yeah. What is the determinant of this? Determinant of this is 1. If you see, if you check cos square theta by 2 minus minus plus sin square theta by 2, these two will be cancelled. You may be wondering there is no phi or how. So at the end of the day, they are cancelling each other out. Okay. So this is the rotation matrix, which is the rotation of theta by 2 around z axis. Okay. Rotation of a spin vector differs from that of a spatial vector. Okay. So if this is spin vector is called a spinner. All right. So this is your spin vector. I hope you understood this one. Yeah. Okay. Okay. Now let's do some numericals. Okay. So the commutation relation that we wrote of sigma, we have to prove it. Let's prove it. So that even if it comes as a numerical or something, so you should be able to solve it, or it will really help in your uh, interviews. Okay, because interviews, it's not like they will ask you like the formulas. You have to kind of derive it. Okay, and exams like TIFR also, you have to use some form derivation. You just It's not just direct formula based. So we need to derive such things. It's just not for semester exams. We need to derive it to understand what's actually going on inside. Okay. So the question is the commutation relation. Calculate the commutation relation sigma I, sigma z, sigma j, where j is equal to xyz, okay, and sigma I at the Pauli matrices. Okay. Okay. So we have to check it. We will check it by what? We will check it simply by taking the sigma x, sigma y, sigma z, all of them. Okay, and after that we have to write a generalized formula because we are asked sigma I, sigma z. We are not asked x, y, z. So we have to write a generalized formula at the end using the example. Okay, so let's solve it. Okay, you can take 2 3 minutes and try on your own. You can pause the video. After that, you can try on your own. After that, you can continue the video. So we'll take simplify. We know sigma x is what 0 1 1 0. Sigma y is 0 minus I 0. Sigma z is 1 0 0 minus 1. Okay. So first commutation relation sigma x sigma y we do. Okay. So what is the commutation formula we know between two like operators A B is equal to AB minus BA. Okay. So sigma x sigma y minus sigma y sigma x. Right. So sigma x sigma y is 0 1 1 0. Simply matrix multiplication and nothing else. 0 minus I 0 minus 0 minus I 0 into sigma x is 0 1 1 0. So this is the one this multiplication. We just have to multiply now 0 I 0. So this is 0 0 0. Now minus I 0. So this is the one minus 0 minus I 0 0 0 0 I 0. Okay. So now we just have to do it this one. So okay, I will do it directly. I minus minus I 2I. Okay, 0 0 minus I minus 2I. So if I take the 2I out, so this is 1 0 0 minus 1. Okay, you can check. See, this is your what? This is your sigma z, isn't it? So this is 2I sigma z. So the commutation between sigma x and sigma y is what? 2I. Got it? This is the answer. Also no. This is only sigma x sigma y. Exactly like that, you can prove sigma y sigma z as 2y sigma x and sigma z sigma y is equal to 2y. I will leave it up to you to prove it. Okay, sorry, I really did a mistake here. Sorry, I wrote it twice. Sigma z sigma x 2y sigma y. Okay, yeah, please prove it. Otherwise, let me prove it this one. Sigma y sigma z. So sigma y sigma z is what? Sigma y sigma z minus sigma z sigma y. So sigma y is what? 0 minus I 0. This is 1 0 0 minus 1 minus 1 0 0 minus 1 0 minus I 0. Okay, yeah. So do it. Multiplication 0 0 0 I. Okay, 0. Sorry. I. I. Then this is 0 minus. Okay. This is now 0 0. This is minus. This is what? Minus I. Na? Okay. Minus I 0. So this is minus I. Now this is 0. This is minus I. Okay. 0 0. Yeah. So 0. This is I minus minus plus I 2I. This is 2I. If I take 2I out, so it will be 2I whole into 0 1 1 0. So this is your what? This is your sigma x, isn't it? So this is your 2I sigma x. Sigma y sigma z is what? 2I. Is it clear? Yeah. Yeah. Oh. So now we'll try to write a generalized form. Okay. So we have the formulas. So sigma x is sigma y. Let me just write it again. 2x is sigma z. So if I take it as I, this is as j, sorry. So 2I is a must. Okay. Now the third one is sigma k, isn't it? I, j is leading to k. Okay. And what will be here? There will be another term here. Okay. Because see, you can say this is the end. No. Because see, if I do the reverse thing, if I take the other side, so it will become minus 2I sigma k, right? So there is a minus here coming. It's coming because of the reverse of the order. So we need to give it something here so that suppose I and j are in order, it will give me plus 1. Okay. If I and j are not in order, like the opposite order, it will give me minus 1. And if I is equal to j, it will give me 0 because sigma x commutation is 0, isn't it? Yeah. So we have to give there something. So that is called Levici beta. Okay. This is sigma ijk. Hmm. It means what? It means sigma ijk is what? Sigma ijk is it is plus 1 if what? Ijk are in order, or we can say the term is are in cylindrical permutation. Okay, and this is the term for it. Like in particular order, minus 1 if they are in anti-cylindrical permutation. And 0 if they are equal. If I is equal to j, then it's 0. Because sigma x, sigma y, if they become equal, the commutation will become 0. Okay. So this is the one we needed. So this is the final form. I hope you understood. I hope you got an idea. Okay. और edit करिए ना, last to critical case, last to critical rejects. अरे ये करिए ना, edit करिए ना. Damn this. Okay. So we'll move to the next part. Okay. We will now do what? Question number two. Write down. Using the basis vectors of S Z eigenvectors, calculate calculate SI plus half and SI minus half SI minus half where I is equal to x y z, okay, and where you sorry plus half and minus half are what eigenvectors of sz with with eigenvalues eigenvalues plus h cut by 2 and minus h cut by 2 respectively. Okay, is it clear? Yeah. So calculate the what? Using the eigenvalue, calculate SI this, SI that, and the eigenvalues of it. So you try this question first, then you will see the solution. Let me do it. You can pause the video. Solution. So we know Sx, Sy, Sz is what? Sx is equal to h cut by 2 sigma x. So h cut by 2 0 1 1 0. Sy is what? H cut by 2 sigma y. So h cut by 2 0 minus I 0. Hz is what? H cut by 2 sigma z. So h cut by 2 1 0 0 minus 1. Okay. So if we denote this plus half, okay, we'll denote it as the vector will be eigenvector will be 1 0. The minus half is eigenvector will be what? 0 1. Right. So Sx plus half will be what? It will be what? Sx 1 0. So Sx I will write Sx here. Sx is h cut by 2. H cut by 2 0 1 1 0, and this is 1 0. Okay. So if I multiply it, I will get 0 0. Okay. 1 0. So okay. No. This is 2 plus 2 now. This is 2. 1 plus 2. This is 2 plus 1. So the answer will be 2 plus 1. Okay, yeah. So 2 plus 1, that means 0 1. Sorry, my bad. So h cut by 2 0 1. I will write it again. 1 0 is equal to h cut by 2 0. Sorry, I write it like this. Yeah, did you get it? Exactly. Sx minus half. That will give me what? Sx is what? H cut by 2 0 1 1 0 minus half is 0 1. So that will give me what? H cut by 2. This is 0 1 0 0. Okay. This is it. Got it? So these are the eigenvectors. Okay, eigenvectors for like this one. Sx plus half, Sx minus half. You can do the exact same thing to these ones also, Sy, Sz. Okay, let me do Sy, you will do Sz. Sy plus half, that will be h cut by 2. Sy value is 0 minus I is 0, and your plus half is what? 1 0. So that will be h cut by 2 0 0 I 0. So I. Okay, this is the eigenvector. Okay, this one. Now Sy minus half is what? H cut by 2 0 minus I 0 0 1. Okay, so this will give me h cut by 2 0 minus I 0 0. Yeah, this is what? Sy minus. Okay, so the same way you can do Sz plus half, you can do Sz plus half, and Sz minus. Okay, so this is one. I hope you got the question, understood it. Yeah. So we can do another thing here. See, this is 0 1. We are getting applying plus half. We are getting 0. 0 1 is actually minus half. So h cut by 2 what? Minus. Right? Because minus of eigenvector is 0. Okay. And after applying plus minus half, we are getting 0 1. Sorry, 1 0. So we can write S6 minus half is equal to h cut by 2 plus half. Got it? Yeah. You can do the same things here also. You can here take the I out. Okay. Take the I out, so it will be I h cut by 2 0 1. 0 1 is actually what? Minus half. Like eigenvector. Minus half state. Right? And here take I out. So I h cut by 2 minus I h cut by 2 1 0. 1 0 is what? Plus half. Plus half state. Yeah. So these are the things. So let me write it again. The things. So Sx plus half if I do, if I operate Sx on plus half. Plus half means exactly what? Ms has two values, that is plus half minus half. Okay, for spin half. So I'm writing that here. Okay, like plus half and minus half. You can do also like this is up, this is down. So you can write like this also. There's no problem. It depends on you. Sx up, Sx down. If you put Sx up, so you will get what? H cut by 2 down state. Okay, Sx down, you're getting H cut by 2 up state. So this is, you can do it, no problem. Okay. So I'm getting here what? H cut by 2 uh, plus minus half. Okay, and Sx minus half if I'm doing operating. So I'm getting H cut by 2 plus half. Okay, and I just proved it there. Now Sy plus half. Okay, by 2 I will get IH cut by 2 minus half. Alright, and Sy minus half by 2 I will get IH cut by 2 minus IH cut by 2 plus half. Is it alright? No. Now SZ. The thing about SZ is SZ has already an eigenvalue, that is MS H cut. Okay. So whatever there is inside this, I will get it here. There will be no turning of signs like minus, plus, plus, no. So if I put SZ plus half, I will obviously get it as H cut by 2 plus half. Okay. If I do SZ minus half, I will obviously get it as minus H cut by 2 minus. Okay. Alright. Yeah. See, why you can ask me why we were getting like minus here, plus here, and plus here, minus here in case of Sx and Sy. There is a question you can ask me. Okay. So, what is the answer for that? Can you tell me why it is not changing in case of y plus remains plus? In case of Sz, the state remains the same. The state remains the same, but it changes when I apply Sx and Sy. Why? Because Sx is what? Sx can also be written as S plus what? Plus S minus whole divided by 2, right? And Sy can be written as S plus minus S minus whole divided by 2I. If you remember, because see, Sx is equal to, okay, let me prove it also. Sx is equal to S plus is equal to what? Sx plus Isy. S minus is what? Sx minus Isy. Yeah. So if I add them, Sx, S plus plus S minus, these two are cancelled out, so 2 Sx. So Sx is equal to what? S plus I S minus divided by 2. Okay, this is this one. Now Sy is what? If I subtract them, S plus minus S minus, if I subtract them, these two will be cancelled, so they will be added. 2I Sy. So Sy is what? S plus minus S minus divided by 2I. Okay, yeah, alright. So these two are the values. So when I'm applying a plus half in case of Sx, see, you see yourself plus half. Okay. So let me do this half whole into S plus S minus, and is getting applied on plus half. Okay. So plus half. Okay. Now the thing here is okay, this S plus when it is applied on any value of m, what is the thing? What is it? H cut root over of S minus m whole into S plus m plus 1, and it is m plus 1. Okay, yeah. When S minus is applied, this is raising operator, lowering operator of what? Of spin angular momentum. Please write it down also, this formula. S plus m, S minus m plus 1, and this is m minus 1. This two formula is very important again. Okay, so let me do this one then. Sx plus half. Sx plus half. Sx is what? Half whole into S plus S minus and plus half. Okay, this is the m value here. So half S plus. Okay, first I will do S plus half plus S minus plus half. Yeah. So that gives me half root over of s, s minus m, s minus m, s plus m plus 1. Okay. So what is s here? S is your half only. Yeah. S is your half. Because s is your half. For s value of half, ms is plus half minus half. Got it? If s value is 1, ms value is minus 101. How? Because it is all has always 2s plus 1 values. Okay, m has always 2s plus 1 values. So as m s is half, so m will have 2s plus 1, that is 2 values, that is minus half and plus half. So s value is already half. So half minus half, half plus half minus 1, sorry, plus 1, sorry. And this will be raised to one value, ms plus 1. So there will be 3 by 2. Okay, but the thing is, there is no 3 by 2. ms doesn't have any 3 by 2 value, and eventually this term is becoming 0. So we are not getting plus 1. So let me do this one. Plus, I hope this is understandable because these are very basic things. I don't want to explain them too much. Okay, that will cost us a lot of time. These things actually, these things need to be figured out on their own. Okay, I won't even if you don't understand, I won't be able to explain to you. These are like, this will take time. Okay, if this is new for you, this will take time. This will take 3 4 days maximum. If you sit down and just you think like I have to do it, then it will take 2 3 days, and after that you will become a master. Okay, don't worry. So s minus is what, s plus m. So half plus half, then half minus half plus 1, and this one half ms minus half. Okay, so what, minus half. So that's why I'm getting minus 1. This is 1, this is 1. So that's why I'm getting what, and h cut is also there, my bad. H cut is also there here. So h cut, and this is your what. Did you get it? I know I have done it very fast, but this is the way to do it. Otherwise, because there are basic things you studied in masters, so I expect you to, like, I assume that you have done it before. Okay, so yeah. So now I leave it to you to do the s minus thing. Sorry, s do for s plus xs minus 1. You do it now. I'm giving you 2 minutes. I did the sx plus r. You do the sx minus r1. Okay, could you do it? Okay, let me do one for a sy or sy plus half. Okay, so sy, what is the for this one for sy? S plus minus s minus divided by whole divided by 2y. Okay, so let me do it. So sy plus half will be what? Whole 1 by 2y. Okay, s plus minus s minus, and it will act on plus half. So 1 by 2y, this will be s plus half minus s minus plus half. Okay, all right. So 1 by 2y, now s plus is what we know, s minus m, s plus m plus 1, h cut is outside, and ms plus 1. Okay, minus s minus how much, s plus m, s minus m plus 1, h cut is outside, and ms minus 1, lowering operator. Okay, 1 by 2y, so this becomes h cut. Okay, s is already half, so half minus half. Okay, this is giving me 0. Half minus half, and whatever it is, it doesn't matter. This is 0. ms plus half. So this is 3 by 2. So again, 3 by 2 doesn't exist. Okay, 3 by 2 doesn't exist in anything. Like we have only ms value is what? Plus half minus half. So 3 by 2 doesn't exist. So this is already, this term is non valid, and this is also 0. Minus h cut. Okay. S plus half, S plus m. S plus m. So that is half plus half and half minus half plus 1. And this one m is minus half. Half minus 1. This is your half now. M is minus 1. This is minus half. Okay. So this is minus. Got it? Yeah. So half is 1. This is 1. So this is giving me 1 by 2i minus h cut. Okay. Minus 1. Don't take this inside and make it plus. This is a different. This is a state. This is a value. Eigenvalue. Okay. So minus h cut by 2i minus half state. So this is, I can write, if I take the I to numerator, it will, the minus will disappear. I don't want to explain it because it's a very easy stuff. Okay, so this is the thing for sy plus half. So I can see the state is changing here. That is because of the lowering operator. Raising operator could not raise this value because it's 3 by 2, which is not there. So lowering operator is giving me minus half, which is there in the basis. It has two bases like plus half, minus half. S is the basis, that is S has half, and the basis there are two values plus half, two states, that is plus half and minus half. Okay, I hope it is clear. Yeah, it's clear. That's why SZ doesn't have any change in state because SZ has eigenvalue ms cut, and it doesn't have any expression like this s plus s minus. It doesn't come in the expression of s plus s minus, so there is no raising and lowering operator in the value of sz. That's why I am getting the same state that I operated on. Okay. Yeah. Okay. Now I'll be moving into a bit of tricky zone. Okay. So be patient and we'll solve the question. The question number 3. Question number 3. Okay. If the z component of an electron spin is plus half plus h cut by 2, what is the probability, what is the probability that what is the probability that its component along, what's the probability that its component along a direction z dash, its component along is in direction z dash, that forms an angle, that forms an angle theta, okay, with the z axis, with the z axis equals plus h cut by 2 or minus h cut by 2 as shown in the figure. Okay. Next also, what is the what is the average value of what is the average value of the spin? What is the average value of the spin along z dash? Okay, z dash, and there is a diagram for it. The diagram is like this. This is a z, this is x, y, and this is the z dash vector here. Okay, this is the n cap, and this is theta, and this is your phi. Okay, yeah. So this is the question we have. This is the figure of answer. Okay. If the z component of an electron spin is plus h cut by 2, what's the probability that its component along the direction z dash that forms an angle theta with the z axis equals plus h cut by 2 or minus h cut by 2? What is the average value of the spin along z dash? Let's try this question first, then only I will solve it. Okay, it'll take 2 minutes. Okay, so let's start this question. First of all, it is asking what is the probability that is component along z direction equals plus h cut by 2 minus h cut by 2. So let me start this question then. See, the present state of the electron is what? Plus half. Present state of the electron is plus half. Spin operator component along z dash is what? Spin component is z dash is equal to, how will I write it? S vector dot n cap along n cap. So this S vector is always what? H cut by 2 sigma dot n cap. Okay. Now n is a unit vector along what? Unit vector along z dash. If you see in the diagram, unit vector along z dash, right? This is the unit vector n cap along z dash. So can I write like, you remember, if you remember, can I write like this? N cap is equal to, okay, x cap sine theta cos phi, okay, plus y cap sine theta sine phi, hmm, plus z cap cos theta, right? If you remember, r cap we used to write in like this coordinates, theta and phi. N cap is sine theta cos phi, okay, plus y cap sine theta sine phi, z cap cos theta, right? So so what will be this h dot n? H dot n will be what? H dot n cap will be what? Sx Sx x cap is Sx sine theta cos phi dot product, so the cap won't be there, plus Sy sine theta sine phi plus Sj um, cos theta. Okay, so this is the H dot n. Yeah, the eigenvalue Sj dash or what? Plus h cut by 2 minus h cut by 2 as given in the question. Okay, so if I write Hz dash, can I write like this? Eigenvalue of z dash, okay, is equal to, it can be written as a linear combination of two basis eigenvectors, that is plus half This is basic quantum mechanics. Okay, it's not anything different. Minus. All right. Yeah. So can write Sz dash plus half dash is equal to h cut by 2 plus half dash. Yeah, is it correct? Yeah. So again, if I write the minus dash is equal to linear combination of two eigenvectors, that is mm, plus half plus d whole into minus. Is it all right? So Sj dash minus half I can write what h cut by 2 minus h cut by 2 minus dash. Okay, all right. So ABCD are actually complex constants. So now what? Now what? Now what can we do? Uh, what can we do is we can do one thing. Okay, let me do one thing. SJ dash. Okay, yeah, right. Okay, yeah, this is your SJ dash. SJ dash. So this whole thing is a SJ dash, right? So let's do one thing. In place of SJ dash, let's put this one. Okay, and in place of half dash, we'll put this one. Okay, yeah, let's do it. So SJ dash is a what? Sx sine theta cos phi plus Sy sine theta sine phi plus Sz cos theta. Okay, whole into what is that? Plus half dash, that is a plus half plus b minus half. Okay, is equal to what? Is equal to what? H cut by 2 plus half dash. So h cut by 2 plus half dash is this one. So a plus half plus b minus half. Okay, yeah, all right. So we know the relations, like Sx plus half is how much, Sx minus half is how much. We had just done it in the previous question. Okay, I had explained to you so much. This one. So let's do it. Let's just open this one, multiply this one. Okay, if we do this, that will be Sx. Okay, a Sx plus half will be h cut by 2 minus half, correct? Because Sx will change it. Now sin theta cos phi. Sin theta cos phi. We'll rearrange it, don't worry. Now Sx b, okay, b Sx will act on minus half, that will give me h cut by 2 plus half, right? Yeah, and this is sin theta cos phi. Now Sy will act on this, so plus a Sy acts on plus half, Sy acts on plus half. This will give me I h cut by 2 minus half. Okay, and sin theta sin phi. Now plus you need to be really patient and really focused while solving these questions. You cannot be really absent-minded. Okay, Sy will act on minus half. That will give me minus b I h cut by 2, because it will give me minus I h cut by 2 actually. That's why I took the minus out, and minus will be changed to plus half, and that will be sin theta sin phi. Okay, now Sj cos theta will give me, it will give me the same eigenvalue. So a h cut by 2 cos plus half cos theta plus sorry, minus b h squared by 2 minus r cos theta, whatever it is, and it will be equal to the right side. Okay, right side will remain as it is, that is h squared by 2 a plus r plus b minus r. Okay, yeah. So now what, we just have to kind of equate the left side and right side. Okay, like the components, like the coefficients of plus half, we will equate it to right side. So see, what are the coefficients of plus half? This one, 2, and 3. Sorry, sorry, 1, 2, and 3. So let's kind of add them and equate it to this one. So if I add them, so first term will be, do it yourself. Okay, don't copy from my side. Bh squared by 2 sine theta cos, sine theta cos phi. Yeah, correct. Sine theta cos phi. Don't copy because there is no point copying. This only you can understand only if you do it on your own. Minus I bh squared by 2 sine theta sine phi. I'm not writing that plus up anymore because I'm just equating the both sides. So plus up will be already, it will eventually get cancelled out. Plus ah squared by 2 cos theta is equal to h squared by 2 a. Correct? I wrote all the components of a. I will do the cancellation now, but let me first write the equations. So now minus up part. So if I write a h squared by 2 sine theta cos phi, sine theta cos phi. Now what is another minus a I h squared by 2 plus a I h squared by 2 sine theta sine phi, sine theta sine phi uh, minus bh squared by 2 minus bh squared by 2 cos theta, minus bh squared by 2 cos theta is equal to h squared by 2 b. Okay, h squared by 2 b. Is that all right? Yeah. Okay. So yeah. So let's do some cancellation and all. All the 2's will be cancelled. So let's write by cancelling all the 2's. So first one will be, and all the h squared also. Simplify as much as we can. B sine theta cos phi minus ib sine theta sine phi plus a cos theta is equal to a. Second equation will be a sine theta cos phi. Do along with me, okay, and do yourself. Don't copy. There will be no point if you copy. Ia sine theta sine phi and minus b cos theta is equal to b. Okay, so these are the two equations. Uh, so how can we proceed from here? If we okay, so the thing is, this is your a. We have to write a and b. So let's take it to this side, and that will be your a whole into 1 minus cos theta is equal to b sin theta cos phi minus I sin theta sin phi. Okay. So uh, so this is a b. B we can write b is equal to a whole into 1 minus cos theta sin theta whole into cos phi minus I sine phi, right? Again, I is known as e to the I phi, isn't it? Sine theta e to the I phi. Thing is, this must be a unit vector. Okay, this must be a unit vector. Um, A and B must be unit vectors actually because A square plus B square must be equal to 1. Okay, because why? Why? Because this is this one here. So A square plus B square must be equal to 1 coefficients. Um, so let's do one thing. Let's do it A square plus B square here. That is A square 1 minus cos theta whole square sin square theta 2 I phi is equal to 1. Okay. I don't think I can get a solution from here. So I do another thing here. Okay, let's do another thing here. Let's simplify bit B bit more. Let's do that. B is equal to A whole into 1 minus cos theta sin theta and phi. Multiply 1 plus cos theta and both numerator denominator I will get 1 minus cos square theta sin theta whole into 1 minus cos theta e to the power I phi. This is your sin square theta. A sin square theta divided by sin theta 1 minus cos theta I phi. So this is cancelled. Sin theta. So A sin theta divided by 1 minus cos theta. 1 minus cos theta is 2 sin square theta by 2 e to the power I phi. Okay. Okay, if I A into 2 sin theta by 2 cos theta by 2 divided by 2 sin square theta by 2 e to the power I phi. These two got cancelled sin theta by 2. 2 got cancelled. This is cot A cot theta by 2 e to the power I phi. That is A cot theta by 2 e to the power minus I phi. So this is a B. I got B somehow in a very simple term. Um, so B square is equal to A square cot square theta by 2 e to the power minus 2 I phi. Exactly like that we have to do to A. A square. We have to get A somehow. Um, After that we have to put that here. Actually that's the purpose. Because this is what we wrote, right? And after that we have to just take the square added to the probability. I feel like I'm doing some mistake. I don't know. I feel like I'm doing some mistake. Okay, leave this. Try. Okay, I think I made some mistake. That's why I just can't go back now. This up to this is correct, but after it, I think something happened, and it's got messed up. Okay, so you please try this question at home. I'll also try this. I'll let you know in the next class. I have made some mistake here, I think, because we needed to get the value of a and b. Okay, okay let me tell you the solution. You will get a as what a will be. Uh, a will be cos theta by 2, b will be sin square theta by 2, yeah, and sorry, sin theta by 2, sin theta by 2, and there will be e to the power I phi by 2. So, plus half dash will be cos theta by 2 plus half plus plus what? Plus sin theta by 2 e to the power I phi by 2 minus half. Yeah. Yeah. Now, thing is, plus half and minus half, they're like orthogonal to each other, okay? Plus half dash and minus plus half dash, it's orthogonal 0. So you have to put again this one here and equate it to 0. You will get another, you will get C from there, C and D, okay? And after that, there is a lot of, it's a big long question, okay? You can be asked this in interviews. So please try from there, okay? Make it to 0, get the value of C and D, and then try. Okay. So yeah, that'll be it for today's class. We'll be doing more questions. Right. Okay then. See you in the next class. Okay. Thank you very much.